Hello everyone. Welcome to our presentation. Today I'm excited to introduce our work, EMatch, a unified framework for event-based optical flow and stereo matching. Event cameras are neuromorphic vision sensors that capture pixel-wise brightness changes asynchronously. Unlike traditional frame-based cameras, event sensors offer microsecond-level latency, high dynamic range, and low power consumption, making them ideal for high-speed and high-contrast scenarios. In 3D vision, event-based perception tasks can be roughly divided into two groups: temporal tasks like optical flow estimation that captures motion over time, and spatial tasks like stereo matching that measures disparity between two viewpoints. However, most existing works treat these as separate problems, designing distinct models for each. This separation overlooks the strong correlation between temporal and spatial domains. In essence, both tasks are about matching pixels across event streams. So we asked, can we build a single model that handles both optical flow and stereo matching efficiently and accurately? That's the motivation behind EMatch. The core idea of EMatch is simple yet powerful. We reformulate both optical flow and stereo matching as pixel-wise correspondence matching problems within a shared representation space. In optical flow, we match events over time. In stereo matching, we match events across viewpoints. EMatch treats both as two instances of the same matching process. This unification allows the model to learn transferable representations, enabling cross-task training, multitask unification, and better generalization without retraining for each task. Our unified network consists of four components: temporal recurrent network, spatial contextual attention, correspondence matching, and refinement. Since event data are sparse and asynchronous, we design TRN to recurrently aggregate temporal information. It splits the event voxel into temporal groups and processes them sequentially using stacked CONVGRUs. This preserves motion continuity and produces temporally rich features. Event data often lack information in static regions. To address this, SCA introduces self-attention and cross-attention modules that fill in missing pixels using contextual cues. As a result, we obtain dense, discriminative feature maps that work well for both temporal and spatial tasks. We then perform a feature similarity search between the reference and target event maps. Using correlation volumes and softmax normalized similarity scores, we compute dense displacement fields, which correspond to optical flow or disparity. Finally, we refine predictions iteratively and at multiple scales, enhancing local accuracy and edge sharpness. Together, these modules form a compact and efficient framework that works seamlessly for both event-based flow and stereo estimation. We evaluated EMatch on two large-scale benchmarks, DSEC and MVSEC. On DSEC, EMatch achieves state-of-the-art performance in both optical flow and stereo tasks. Compared to task-specific methods like ERAFT and TSNet, our unified model achieves lower endpoint pixel errors while using a single architecture. On MVSEC, EMatch also generalizes well across both indoor and outdoor environments, showing robust performance even under challenging lighting and motion conditions. Qualitative results further show that EMatch generates smoother motion fields and sharper disparity boundaries, effectively combining the strengths of both tasks. Moreover, when we perform multitask training, optical flow and stereo matching both improve, demonstrating the benefit of cross-task transfer between temporal and spatial perception. In conclusion, EMatch demonstrates that temporal and spatial perception can be unified elegantly within one framework, opening new possibilities for event-based 3D vision and neuromorphic perception systems. Thank you for watching, and we hope EMatch inspires further exploration into unified event-based vision. If you're interested, our code and pre-trained models are publicly available at github.com/bit-vision/EMatch.